Okay, here's something kind of similar. It's on a banked road.
Okay.
So, I'm not quite sure what equation they used here. I'm given an angle and it wants to know the maximum speed. Well, what's it saying?
Whoa.
The radius, it wants to know the radius.
Oh, perfect. So, when you say you don't know what the equation to use, you're always going to follow the same procedure.
Mm-hmm.
You're going to do...
But if I don't know the equation, then what good does that do?
The equations are like your A is equal to V squared over R, your force equal to mass
but
times
that doesn't
acceleration.
take care of the angle.
Sure. Well, that's because we don't really use an equation. You do your sum of the forces in your X and your Y.
Then you use an equation.
That's basically it, I guess. But it's not like it's a specific equation that somebody came down and derived. You derived it yourself.
If it was.
Yeah, if it was easier, then everybody would do it.
No,
Yeah.
because it's math, and math scares people away.
I know, right? But if it was easy, then everybody would do it.
No, because it's math, and math scares people away.
What I'm saying is math was easy. If math was easy, then everybody would do it.
But math isn't easy.
That's
And
what I'm saying.
physics, even if it was simpler math, wouldn't be any easier.
So, what do? What are your sum of the forces? Because that is your equation. You just have to
All I
derive
know
it.
is that the math cancels out, and it's not relevant.
Okay. Does it? Is it?
No, it's not.
Nice.
It doesn't tell me that, but I guess no, it isn't.
Cool. Sometimes it is.
Well, in this case, it isn't.
Yeah.
In the next problem, it will be.
Nice. Okay. So, what do I write then? What are your sum of the forces?
Well, for y, we have the normal force, and actually, since it's a curve, it's kind of divided between x and y for normal force.
Mm-hmm.
So I guess you have the sine of the normal for y and the cosine of that for x.
You sure?
No,
What kind of angle is it?
it's that angle.
Hmm. So if you draw a picture,
It gave me a picture.
what's that?
It gave me a picture. Why do you draw it?
Because you can write on this one.
I can write on this one. It just messes up my screen.
There you go. Want to write on your picture?
I don't want to write on my screen.
So you have this car. There's your normal.
Mm-hmm.
Are you going to be using that angle or this angle?
The first one.
The first one?
Mm-hmm.
To be that theta?
I don't know.
They look kind of the same. It's not. It was a dumb drawing. My bad. I take fault
See,
for that.
that's why the drawings are helpful.
Oh, they are helpful, trust me. So this is the theta that you're using, right?
Okay.
Do you know how to? It's geometry. This
Well, I've
is
taken
your
geometry before.
yeah. So this is that angle right there, and then this angle is that angle right there.
Whatever you say.
It is. Do you not believe me?
I don't believe in mathematics.
It's not mathematics. It's geometry.
It's still mathematics.
Okay. So what else do they have on it?
Well, there's no friction in this case.
There's not?
No, but there is later on.
Nice.
Because this bank is covered with ice. And as
Okay.
we all know, ice has no friction.
Yes, that is true.
Has so false.
Gravity.
And we know the speed, but that's not really a force.
Yeah.
It's a velocity, but that's no force.
Yeah.
So basically, that's all the forces we have.
Cool.
Well, we have an acceleration, but that's still not a force.
Yeah. Is it going around the corner, speeding up?
Yes. Well, yeah, it's accelerating. No, it's just gravity. Never mind.
Okay.
It's just going around at a constant speed of 45 kilometers.
So in the sum of the forces in the y, you have your normal
Mm-hmm.
times by the what instead of sine?
Cosine.
Why would it be the cosine?
Because it's not the sine.
Yeah. Because we're looking for that angle, and the cosine gives us that part, and the sine gives us the other part.
Mm-hmm.
This is the sum of the forces of y, and that minus gravity, so mass times, what is it? Gravity? Yeah,
Well, that's normal.
that is equal to 0. So what are the sum of the forces in the x then?
M times the sine and might be the same. Because we're not exactly accelerating. Well, I guess, well, our velocity is changing.
Are you going around a corner?
Yeah.
So then you'll have centripetal acceleration.
There's no such thing.
What's that?
There's no such thing.
There's no such thing as centripetal force.
There's no such thing as centripetal acceleration either.
This?
It's fictitious.
So?
So there's no such thing.
It's got a name, and we use it. What else would you call it then?
A force.
That's a force.
Exactly.
And that's not a force.
I don't know.
It's an acceleration.
Okay, I'll just call it an acceleration.
That's an acceleration.
That's a different type of acceleration.
So what's this type of acceleration then?
A different one.
A different one. So this is the different acceleration?
Yes.
That's what you're going to call for the rest of your physics career? You're going to call
Yes.
the centripetal acceleration the different acceleration?
Because my physics career is not going to be that long.
Anyway, this is equal to your mass times the centripetal acceleration.
Okay. Or just mass times acceleration.
Mass times acceleration, but you have to know what acceleration because it's going to be important.
Okay.
Does it say the velocity at that exact moment?
It says it keeps a constant velocity.
Oh, so it's not accelerating. Okay, good. It's not accelerating in tangentially.
Exactly.
Cool. So now what?
We have to find an equation.
These are your equations.
But that takes too much time. I mean, they have equations written out.
Well, if you don't know them, what's the point?
To know them.
So
You memorize them.
that's kind of ridiculous.
No, it's not. It's like, why else would they give you an equation sheet on the test?
Do you have the equation sheet here?
No.
Oh. And I never bothered memorizing it because I knew exactly how to drive it. It's not that hard to drive.
And it's hard to drive.
Well, what would you do? What do you do from here?
Go to the internet and look up the equation. I
There's
know
no
it has
end.
something to do with tangent, I know it has something to do with velocity, and I know it has something to do with radius.
Cool, okay. What did we use before for your tangent or centripetal acceleration?
I don't remember.
I'll help. I'll do the hard part.
That was the easiest part you could even do.
Okay. What goes on top?
V squared. R.
There you go. This and this are basically the only formulas you need for this stuff right here.
Yeah, but I still need to know how to implement the angle.
Alright?
Yeah.
That's it.
The sine.
You will be implementing the angle right here. Because if you solve for n, right, you'll get m times g
Mm-hmm.
divided by the cosine of theta. You put that right here. Then that implements the angle right there. It's going to be your mg times the tangent of theta.
Okay.
I'll try that out, yeah. So it's mg times the tangent of theta. And what is that equal to?
It's equal to acceleration, which is v squared over r.
Yeah. And see here, you write the law of masses cancel. Root. What are we looking for? R?
R.
Cool. How do you find R?
I presume you just do g times the tangent divided by the velocity squared.
Yeah. Or just switch places with that.
Or you could do that. or v squared over g times, so that would be, so what's 45? So it's, would, to change from kilometers to meters, should I multiply by 1,000?
Yeah. Is it kilometers per hour?
Yes. And I have to divide by 60, right?
Yeah. 3,600
2,600.
hours per second, hours in a second.
You mean 3,600?
Yeah, that's what I said. What did I say?
You said 2,000.
Oh my gosh, what am I thinking?
Okay, so 12.5 meters per second. Okay, so I will solve squared using a calculator. Well, there's nothing wrong with my calculator.
No, I know. I think it's funny because my math teacher, he doesn't like calculators at all. He likes software on the computer.
Yeah, but I can easily turn my software into a calculator.
I know, that's what software on the calculator on the computer is. It's like it's a glorified calculator. He just thinks it's funny. I think it's funny because he really doesn't like them.